this. What's that? One over x. Good. Okay, now how about if I ask you for this? So what rule do you have to use?
Đừng ngủ, ngủ là thấy á.
What rule do you have to use for this one? The chain rule. Okay, what does the chain rule say? The chain rule says that if you want to know the derivative of f of g of x, right? That's what the chain rule answers. So the chain rule says that that derivative is times right? So here we have, so we refer to f as the outside function usually, and we refer to g as the what? The inside function, right? So then, what is the outside function in this question? What's the outside function? ln, right? Log is the outside function. And what is the inside function? X cubed plus x squared, right? So therefore the derivative will be the derivative of the outside function, but you don't put in x into that, you put in g. So what is, g means the inside function. So the derivative of the outside function is ln, so its derivative is what? 1 over x. You just told me 1 over x. But you don't put in x, you put in g. And g means the inside function. So you don't put in x, you put in what? X cubed plus x squared. So it's not 1 over x, it's 1 over x cubed plus x squared, right? So that's this part. Right? And then we have another part, which is this. So g is what again? X cubed plus x squared, so the derivative of that is what? 3x squared plus 2x, right? So that's the answer. Okay, does everyone follow that pattern? Yeah? Okay, so any question about that? So the derivative of this is this. Okay. So today we want to talk about something called, the next set of homework that you have to do is called that. Implicit differentiation. So what are they talking about? So, like if I give you this function, and I ask you to find the derivative, everybody should be able to do that at this point, right? Okay? And what does, and just to remind you, what does the derivative tell you? So like say, what is the derivative for this? Is, right, like that. And what does that tell you? Why bother doing that? What does that tell you? That's supposed to tell you something, otherwise we wouldn't do it. It's supposed to tell you something about the original function. What does it tell you about the original function? It's supposed to tell you about the slope of the original function. So, okay, I don't really know what this function looks like. But let's say, how about if we try to draw it? It's going to be hard to draw, but how about when x equals 0, what is y equal to? 0. So at least I know it goes through this point, right? Okay, and the rest of it I don't really know what it looks like, right? I have an idea because it's a third order function. The highest degree is third degree function. I actually think that it probably looks something like, some kind of shape like that. Just like I know a second degree is something like that, right? But maybe you don't know that, but somewhere along the line I learned that. But okay, suppose, we don't know what it looks like, but I'll just say, oh, suppose it looks like that. I don't, just pretend. Okay? Now, okay, so whatever it looks like, well, how about one more thing? How about when x is 1, what is y? When x is 1, y is 6, right? Let's put that. When x is 1, y is 6. Let's erase this and just put that. And how about when x is 2? When x is 2, what do you get? 8 plus 20, right? 28, right? So, okay, so we just have 3 points. We don't really know what this looks like. Okay? Right? I'll just pretend it looks like this. Okay? Something like that. Okay? So whatever. Now we also calculated the derivative. So what is the derivative supposed to tell you? What is the derivative supposed to tell you? The rate of change, or the slope. So, how about if I want to know the rate of change here? That means, here means where? Where is here? At 0, 0, right? But the derivative doesn't need to know what y is. The derivative just says, tell me what x is, and I'll tell you the slope. So what x value am I talking about here? 0. So when I put in 0, what do I get for y prime? 0. So what does that mean? That means the slope is flat at this point. So I drew it wrong, because the way I drew it, the slope would be like that. That's not flat, right? Right? That's not flat. So it doesn't look like that. So maybe I could redraw it, so that it at least looks kind of flat. So maybe it looks like this. Okay? So that means that it's flat here, maybe. Okay? So that's what the derivative tells you, is the slope at different points. How about here? What's the slope there? How do I know that? Again, the derivative tells me. And the derivative, and what are the coordinates at this point? 1, 6. But the derivative doesn't need to know what the y value is to give you the slope. Just asks you for the x value. So what is the slope there? So that there means when x is 1, so what is the slope? 3 plus 10, right? Right? 3 plus 10, so that's 13. So the slope here is 13. Okay? So that might be, maybe the way I drew it isn't so bad for that. That could be 13, I don't know. Okay, and how about here? What's the slope there? So what's the x-coordinate of that point? 2. So then what do I get? 4 times 3 is 12 plus 40, right? No, I'm sorry, plus 20. So 12 plus 20, right? So this apparently has a slope of 32, right? 12 plus 20 is 32. Okay? So what does the derivative tell you? The slope at different places. That's also called the instantaneous. Did I spell that right? Instantaneous rate of change. Now forget about the word instantaneous. What does rate of change mean? It means the slope, right? The rate of change is the slope. Right? How quickly it's changing means the slope. Right? And the instantaneous rate of change means the slope here as opposed to here, because the rate of change is different at different places on this curve. So we really want to talk about the instantaneous rate of change. We could talk about the average rate of change between here and here, for example. And by that we mean the slope of this line, of the line that connects those 2 points. That would be the average rate of change. But we're not asking for that. We're asking for the instantaneous rate of change, or the slope of the tangent line. Okay, does this make sense? So it's the how quickly things are changing, whatever things happen to be. This might be profit, this might be cost, this might be lots of different things. It's just how quickly it's changing, the rate of change. Okay, does this make sense? Okay, now, suppose we had a function like this. Suppose we had a function like that. Now, that's going to have some kind of picture, right? Some kind of graph. Now, as to what it is, it doesn't look so easy to figure it out. Okay? But it should have some, it does have, when x is something, y is something else, right? Maybe it won't be hard to say when x is 0. Maybe we can at least figure that out. How about when x is 0? What is y? So this term will be 0, this term will be 0. So let's make this 27. Okay, so when x is 0, what is y? So that this disappears, and this disappears, so we get, let's make this minus. Okay, now let's try it. So when x is 0, we get y cubed equals 27, so therefore y is 3. So when x is 0, y is 3. So that means this point is on that graph. Okay? Everyone follow that? Actually, there's another point also. No, that's wrong, sorry. It's not another point. So it's just that. Right? Yeah, that's right. Okay, so we have 1 point on the graph. Not very satisfying, right? But if you want to try for another one, we could. Let's say, how about when x is 1? I don't know if that's going to be easy though. How about when x is 1? What do we get? Y plus y cubed plus 1 minus 27 equals 0. That doesn't look too good. Right? That gets not so easy to do. So let's not worry about it. Okay? Anyway, the thing is that it does have, at 1, there's some value. It might not be easy to figure out what it is, but there's some value. Maybe there's more than one value, but at least one value. And at 2, the same thing, and so on. So this thing has some kind of picture also. Right? We'd have to do a lot of work to try and figure out what the picture looks like. Or maybe not, but anyway, it has some picture. So that means that we can also ask about the instantaneous rate of change for this graph as well, or for this function. Okay? Now, it might be better if we wrote y equals da 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 here. Okay, so let's try and do that. Let's, instead of leaving it like this, because usually, like over here, we had y equals something, right? We didn't have x's and y's mixed up, right? So let's try and do that here. So can anybody do that? Y equals? So let's see, how do we start? Any idea about how to start? Well, I'll move the x over. So I have xy plus y cubed minus 27, and I'll put the 27 on the other side also. So I get minus x squared plus 27. Now what should I do? Factor out the y. So that will give me y times x plus y squared equals minus x squared plus 27. Is that right? Yeah. Now what? What? Any other ideas? Okay, I think it's hard. In fact, I tried to write it so that we couldn't do it. Now, I don't know if I actually succeeded, but I tried to write it so that we actually couldn't do it. So you can't separate x and y. Okay, I don't know if that's true here or not, but there are cases where it is true. I think it's true here. So that means I can't write this. Okay? And I can't, in other words, I can't write clearly what y is a function of in terms of x. But that doesn't mean that it doesn't have a picture, right? It still has a picture. When x is something, y is something else. Right? So I can say at least this much. I just can't continue with this part over here. So what do I mean by that? I can say that y is a function of x, but I can't say clearly what that function is. Or they use the word, I can't say it explicitly. So explicitly means so that you can see it visibly. Okay? So we say that y is defined only implicitly as a function of x. Okay? In other words, it's not as good as if it was explicit. Okay? It's only implicitly. So it's kind of less desirable. Okay? But it is at least implicitly defined as a function of x. Okay? Does this make sense? Do you understand what I'm saying? So we have the word implicit and explicit. Okay? So the best scenario is if you could say y explicitly as a function of x, like here. Y is explicitly defined here as a function of x. But here, in this case, it's not, we can't really write it explicitly, or at least we tried it, we weren't able to. But we still say that it is a function of x, so we call it implicitly defined as a function of x. Okay? Does everyone understand the two words implicit and explicit, or explicit and implicit? Okay? All right. So, even though it's only implicitly defined as a function of x, we still might like to know about the instantaneous rates of change. Right? We still might like to know that. But how do we do it? Because all the formulas we learned, like for example this formula, what's this? What was that? The derivative of x to the n is what? Right? You learned that formula, right? All of the formulas, the product rule, and the chain rule, and all those formulas we had, they all were, maybe we didn't mention it, but they were all given when we had an explicit definition of y in terms of x. That was all assuming that. We never considered anything else but that. So we didn't emphasize that, but that was true of every example. Okay? But here we have a case where that isn't, we don't have the explicit function. So we can't do it the same way we did it before. Okay? So we want to learn now about how to do it when we only have implicit function y as a function of x, not explicit. Okay, so that's what the first homework assignment is about. Okay, so let's see how you do it. So let's take that one. Well, maybe I won't take that one just yet, because that one's a little more complicated than we need to do for the first case. Let's suppose we had x plus xy equals 10. Now actually this one you could easily write y explicitly as a function of x. In fact, let's just do it just to make sure that that's possible. Actually, that's not a good example. That's too, let's try, that's too easy. Well, anyway, this one you could definitely do. So, let's do that. What is it? X squared y equals 10 minus 5x. Divide both sides by x squared. Y equals 10 over x squared minus 5 over x. Is that right? Okay, so we did it. That's easy. Then now you could definitely do the derivative of this. But we'll do it the implicit way, but on this case is easier than the other case. So let's just try it on this case first, and we'll try it on the other one after we do it this one, on this one. Do I want to do this one? Yeah, that'll be okay. Okay. So how do we do this? Okay, so here's how you do it. There's a trick, kind of a trick. At least this is kind of my trick anyway. I first write that y is equal to f of x. Okay, that's the idea, right? That y is equal to some function of x, just we can't say what it is explicitly. Okay, so I write that first. And then I rewrite this equation in terms of f instead of in terms of y. Okay, now the book doesn't do it this way, but I think this makes it easier to follow and easier to remember this what you have to do. So I write 5x plus x squared times, instead of saying y, I say times f of x equals 10. Okay? And now what we do is, if these two things are equal, this left side is equal to the right side, then their derivatives should also be equal. The derivative of the left side should also be equal to the derivative of the right side. So I just write that. So I just say the derivative of 5x plus x squared times f of x should be equal to the derivative of 10. Okay? Of course, the derivative of 10 is what? Is 0, right? Derivative of any number is 0. Okay, but we'll say that later. Okay, and now I can rewrite this statement saying that the derivative of the sum of two things is equal to the derivative of the first piece plus the derivative of the second piece, right? So I'll write that like this, the derivative of 5x plus the derivative of the second piece, which is x squared times f of x. Right? Okay, and this is 0, I may as well do it now. It's 0, right? Okay, everyone follow that? Okay, now, going next line. So this piece is very easy to do. It's just the derivative of 5x is simple, it's just 5 plus, and on the other side we have 0, so I'll put that there. Now we need this piece, right? Now, what rule, let me just make it bigger over here, just so you can see it. It's x squared times f of x. We need that, right? The derivative of that, right? That's the last piece we have to figure out. So what rule do we need to do this one? I'll give you choices. Do we need the quotient rule? Or do we need the product rule? Or do we need the chain rule? Or do we need the derivative of a constant rule? Or blah, 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 blah. Which rule do we need to do this problem? Well, I think we need the product rule. Why? Well, the product rule is what? The derivative of, say, let's call it p of x times q of x, right? Will tell us the answer to that, right? And what is it, by the way? It's p prime times, I'm just being sloppy, I should write p prime of x. I'm just being sloppy. P prime times, no, just the regular version of q, plus q prime times the regular version of p. Right? That's called the product rule. And that tells you the derivative of the product of two functions. Right? So I think we need the product rule here. What are the two functions? If this requires the product rule, this should be the product of two functions. So what are the two functions here? What are they? What's p and what's q? Here's p, and here's q. Right? Understand? So what's the derivative of this? According to the product rule. P prime is what? P is x squared, so p prime is what? 2x. And q is what? F of x. We don't have anything more than that, so we just leave it as f of x. Plus, what? Q prime, well q is what? Q is f, so we just say f prime, that's all, we just leave it as f prime. Okay, so we get f prime times p. What is p? X squared. And so that's the answer to this part, right? Don't fall asleep. This is more exciting than a video game. Wait, what's your favorite video game? How about Tsumur Tsumur? Do you know Tsumur Tsumur? No? Has anybody heard of this game called Tsumur Tsumur? No? I'm glad to hear that. It's a Disney game that's really popular in Japan. It's you just have to these little things come up and you just have to find there's all these little anime there, and you just have to find a bunch of them that are the same, and you just trace it, and then another bunch that are the same, and then it's pretty stupid. It's really stupid. I won't tell you the people that I know, I won't give their names away, the people that I know that play that game. That would be bad, since I just called it stupid. But anyway, people just sit there for hours doing this. Like on the train in Tokyo, you can see people doing it on their phone or their iPad mini. And every time you get one, you get a couple points, and then you and if you get enough points, you get a new anime. And so anyway, that's fun. But this is much more fun than that, right? Well, anyway, so where are we? We just got this one, so we just got this piece. So now we have 5 for here. We just finished this piece and 0. So let's put in that piece. What do we have? 2x f of x plus f prime x squared. Okay? You understand what we've done so far? Now what were we trying to do? We started with this function and we want to find the derivative. Right? We started with this function. We said, let's not write it y explicitly in terms of x. Let's do it this new way to find the derivative, because there are going to be times when we can't write it explicitly in terms of x, like that over there. So let's try this new way, and I told you what to do. Okay, and my key was here. I said y is a function of x. So I rewrote, whenever I saw y, I wrote f of x. Okay, now we have it like that. We've sort of finished. Now let's rewrite, let's go back from, instead of writing y equals f of x, let's go backwards, write f of x equals y. Okay, so then now you'll have it in the form that the book does it. Okay, so I'll just switch from f of x to y. So write that up here. What do I get? 5 plus 2x, what do I write next? Y plus, if this is y, what is this? Y prime, right? Y prime x squared equals 0. That's what we have so far. Okay? Now what were we trying to get? The derivative, right? The derivative of f, right? Or in other words, the derivative of y, right? In other words, what's the notation for that? Y prime. Right? We were trying to find y prime. Do you think we have a good shot at getting it now? Yeah, here's an equation with y prime in it. Right? Might not be hard to extract y prime from this. Right? So what do I do? It's easy now, just a simple algebra. What is it? Well, bring these over to the other side, so I get y prime x squared equals minus 5 minus 2xy, right? And then divide by x squared. And that's the answer. Okay, now we have the derivative of our function. What was our function again? It was here. Now we said that actually we could have written it like, where did I write it? Did I erase it? Anyway, I erased it, right? We said we could have written y as a function of x, and then we could have done the derivative that way, easy way. But I wanted to show you this new way. So instead of doing it that way, I just did this. I took the derivative of the left side and set it equal to the derivative of the right side. But my trick, which they don't do in the book, is I switch from y to calling it f of x, and then later I switch back. So they don't do that in the book, and you don't have to do it, but I think it helps you, because at this point here, if you hadn't done that, what would you have here? You would have d, the derivative, x squared y. And I think that you would make a mistake when you do that. I think that if you saw this, and you tried to calculate the derivative of that, I don't think you would use the chain rule. I'm sorry, the product rule. I don't know, what would you use here? What would you do if you saw that? To calculate the derivative of that. What would you do? I don't think you would use the product rule here. I think I've seen students do, I don't know. I don't know. There are a lot of things, wrong things you could do. But I don't think you'd see this as an example of the product rule, that you need the product rule here. But when you see it like this, it's easier to see that you're supposed to use the product rule here. Okay, you don't have to use this extra step, but the point is that when you see this or this way, you have to recognize that it's the product rule that you have to use. Okay? So I don't care if you don't do this, but I think it's better. Okay, so finally we get this. Okay? Now, here's our original function. And suppose we wanted to graph it. What is, well, this might be also hard to graph, but how about just a simple point, just to get us started. So how about when x is 0, no, that doesn't even work. When x is 0, it's not defined there. How about when x is 1? Okay, how about when x is 1? What do we get? When x is 1, we get 5 times plus y equals 10, right? So y equals what? 5, right? Everyone get that? When x equals 1, y equals 5, yeah. So that's this point. So at least I know that point is on the graph, okay? Now, suppose we want to find the derivative at different places. So again, I don't know what this graph looks like. Suppose I want to know the derivative right here. How do I do that? Well, I found the formula for the derivative. Here it is. Now, this looks a little different than our usual formulas for derivatives. Why do I say that? I think that some of you are feeling uneasy when you look at this formula for a derivative. Why? Why does it look different? In what sense is it different? You know, it's funny, sometimes we feel uneasy about something, but we can't say why it is. In fact, usually, when we feel uneasy about something, we can't say what it is. Like, you know, you walk into a room and you feel uncomfortable, but you don't know why. And usually you can't say why. And probably here, you may not be able to know, sometimes we don't even know that we feel uncomfortable. It's like unconscious. And here, you might not even know that you feel uncomfortable. But I suspect that you feel a little uncomfortable here. Why? We found the derivative. Why? What's unusual here? What's different? Nothing? This is just like always? Yeah. We have y in the answer. We never had that before, did we? Whenever we had derivative, it was always like some formula with just x. Right? Like like suppose we had y equals x cubed. What's the derivative of that? It's 3x squared, right? There's no y there, right? Right? So this has y's in it. You're probably, like I said, you might not have even noticed it, but you felt something was different. Okay? And the difference is that here we have y's, only one, but we have y in the derivative. Okay? Now remember when I said before, I said, you want to find the derivative here, I said you only need to know what x was. Right? So you just put in 2 and you got the answer. You just put in 1 and you got the answer. When we do the derivative this way, this new way of calculating derivatives, that's not true anymore. You don't just have to know x. You have to know x and y. It asks you what is x and what is y. So you can't get the answer until you put both of those in. Now, x and y means, from the original function, what are x and y? So, I don't know, this function was kind of hard to deal with. So I don't know all the different values, pairs of x and y's, but at least we found one, right? This one, right? When x was 1, we found that y was what? 5. So at least we can do it for that, one place. Okay, the other places might be hard, like when x is 2, I don't know. What happens when x is 2? What do you get? You get 10, it's not so hard actually. You get 10 plus 4y equals 10, right? That sounds weird. When x is 2, what do you get? You get 2 times the 5 is 10, plus 4y is 10. I guess that means y equals 0, right? Yeah, y equals 0. So 2, 0 is another point, right? How about let's try another 3. What happens then? 15, 9y equals 10, right? So what does that give me? 9y, oh, so it's not so hard to figure out these values. So when x is, what do we get? 15, so we get minus 5. 9y equals minus 5, right? So what is that? Y equals minus 5 over 9. Okay, it's not so hard to find these values, actually. Okay, but anyway, to find the slope at this point, for example, you need to know both x and y when you do it this way. Okay? Because it says not only what x is, but it says what y is. So that's like the price you have to pay for doing it this way, is that you have to have x and y. Okay? So, anyway, so what is the slope here? Now, as I said, I don't know. I'm sure I didn't draw this properly. In fact, I obviously didn't, because it goes through this point. So let me at least put that there. So I don't know what it looks like, but let's say it looks like that. Okay? So now, what is the slope right here? Okay? So how do I do that? I put in 1 and 5 for x and y into here. Right? By the way, we write that, well, all right. So, by the way, we write that like this. Sometimes. So that means, what this just means, x, it means, tell me the derivative when x is 1 and y is 5. Just a kind of shorthand for that. So what do you get? 1 and 5, right? Yeah. So what do you get? Minus 5 times 1. Right? Did I make a mistake?
Yeah, there's minus 5.
Sorry?
There's no x behind minus 5.
There's no what?
There's no x behind minus 5.
Oh, there's no x there?
Yeah, there's no x.
This is not supposed to be x?
It's just minus 5.
Just minus 5? Like that?
Yeah.
Oh, you're right. Right? Y x squared equals, right, you're right. Okay, thank you. Thank you. Sorry about that if I confused everybody. Somebody caught my error. I apologize. Okay, so going back to here though. So it's not 5 times minus 1, 5 times 1 or negative, it's just negative 5 minus, this one is what? 2 times 1 times 5 over 1 squared. Okay, and that's supposed to tell me the derivative, that's supposed to tell me the slope. So what is it? Minus 5 minus 10 is minus 15 over 1. So the slope is minus 15. So the slope, so maybe it looks like that, and the slope is negative, right? In fact, it's negative 15. Okay, do you get it? Everyone get the idea? All right, so that's called implicit differentiation. Now, in this case, we didn't need to do it because we were able to separate y on one side of the original function and x on the other side. So we didn't really need to do it this way. We could have done it in a more straightforward way, but we could also do it this way. Now, in this case, supposedly, we aren't able to write y as a function of x. So we couldn't do it the other way, but we can try to do it using implicit differentiation, the same thing we just tried. Now I'm going to do it with this one also, even though I don't really like to spend so much time, but doing 2 examples is kind of at least the minimal amount usually. Not for me, because in our class we try to rush through things, but anyway, I'll do it because this involves more than the last example, and you need to see this one as well. So how are we going to find the derivative for this function? Okay, again, we think that this has some kind of picture. We think, therefore, that there should be slopes at different places, and we want to find them, but how do we do it? We can't, in this case, write y explicitly as a function of x, so we can't do it the other way, but we can try it using the implicit way. Let me write it again up here. So please catch me quickly if I make a mistake so we don't confuse everybody else. Okay, so the idea is, my technique is first to write y equals f of x. And now, replace everything like that, so I get x times f of x plus, sorry? Yeah, f of x cubed plus x squared minus 27 equals 0. Okay? So I did that first. Next step is, what did I do next after I did that? After I wrote with the f of x like this, next step I did what? I said the derivative of the left side should equal the derivative of the right side. So that's easy to say. So I just write the derivative of this whole thing should equal the derivative of 0, which is, of course, it's just 0. Okay, so I'll just write it again. Okay? Any questions? Okay, now, the derivative of each of this whole thing here is the derivative of the different pieces, right? So I'll write that down too. And I'll just write 0 here. On the right side it's 0, right? Derivative of 0 is 0. Okay, now what? Now we have to use different rules for each piece. Actually, I'm sorry, can I change this? Because I want to make it a little more interesting by doing this. Okay, I'm going to make it a little more interesting. So I have to change this one to that, and this one to that, and this one to that. Okay, can you see that? Sorry. Okay? A little bit more interesting. Now, this is the hardest one to do, so before we do that one, let's do the other ones first. Okay, so let's do this one first. So what's the derivative of 27? 0. So that was easy. And this is also easy. What's this one? Okay, those two were very easy. And now this one. Now what rule do we need to find the derivative of f cubed? What? Chain rule. Right. Chain rule, right? So, what that means, if we're using the chain rule, that means there must be an outside function and an inside function. So what is the inside function? What's the inside function for this piece here? What's the inside function? F. And what's the outside function? Cubing. Cubing, right? Cubing is the outside function, and F is the inside function. The chain rule says it's the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So the derivative of cubing function is what? 3 something to the squared. Right? But it's not something, it's 3f squared. Right? So this one is 3f squared times the derivative of the inside function. Now, if you're confused by this, it means last week's homework, you didn't do it that well. Because we did that, you did this many times in last week's homework. So if you're confused by it, it means you didn't get it. So what does that mean? I don't know. I guess it means you should review last week's homework again. Okay? Because you're supposed to have done that. So anyway, times the derivative of the inside function, which is what? Like that. Okay? So that is the answer for this piece. So now we just have one more piece left. And I made it a little more complicated just to make it a better example. So we just have one more piece. Let me just write that piece over here. So it's this times this. Right? We just have to do that last piece. Okay, so do it. Do it yourself. Do it on paper. Do this one piece so that we can put it in here. Just do that last piece. This last piece, which I rewrote over here for you to see it easily. And so that we can fill it in down here, and then we'll be almost done. Okay? Anybody finish? Okay, what's the first rule you have to use? Product rule. Right? You need the product rule first. So if it's a product rule, that means it should be a problem like this. Right? That's the kind of problem that requires the product rule. So what is the P and what is the Q? P will be here and Q will be here. Right? So P is x and Q is f of x squared. Okay? So of course the product rule tells us that it's going to be P prime times Q plus Q prime times P. Right? So we need both of them. We need all of that. So P prime means the derivative of x, which is what? Just 1, right? So put 1 here. And then times q, well this whole thing is q, so I have to put that. Okay, so we have that piece. And now the next piece is a little tricky. I need q prime and then times p. Well, let's put the p here, because I'll probably forget if I don't. Times x, and then p prime, right? I'm sorry, q prime, right? So that means what? The derivative of this, right? So we need the derivative of that. What rule do we need for this part, for this last piece? We need the chain rule. If we're using the chain rule, what's the outside function here? Squaring. And what's the inside function? F. Right? So we have an outside function and an inside function. Therefore, we can use the chain rule. So the outside function again is what? Squaring. So the derivative of squaring is what? 2 something to the first. But we don't put in x. It's not 2x to the first. It's 2 of this to the first. So it's 2 times f to the first. Well, I don't need to write to the first there, but I could. To the first. That's not prime. That doesn't mean prime. That's to the first power. Okay? Times the derivative of the inside function. What is the inside function? F. F is the inside function. So we want the derivative of that, and we just write that like that. Now again, you don't have to have f there. You could have just left it as y. But I tend to think that you tend to get errors if you do it that way, but you don't have to. Okay, so finally we have that. So that's this piece here. So that goes here. So let's rewrite it over here. So I have f of x squared plus 2 f of x times f prime, am I running out of space, times x. Okay, did I do that right? Or wrong? Is that okay? F of x squared plus 2 f of x f prime times x. Okay. All right? Okay? Now, what did I do here? After I got this part, what did I do next? What did I do to go from here to here? I reversed this step here. Before I put f of x in for y, now I'm going to put y in for f of x. And instead of instead of f prime, I'm going to put y prime. So I'll do the same thing here. So I get what here? F of x squared becomes what? Y squared plus 2y y prime x. Everyone follow that? Everyone follow that? No? What? What don't you follow? Over here, remember at this point, I said let's write y, let's call it f of x. So I did that here, right? And then I just kept going. Did I make a mistake? What's your question? Oh, this one? Ah, that's harder. So you mean this one here? Okay, let's go over that again before we finish. So we have to find this piece, right? So I said, what rule do we need to do this? So what's the answer? It's a product rule because we have the product of this times this. Okay? So that means this we'll call P and this we'll call Q. So the product rule for P times Q is P prime times Q plus Q prime times P. Okay? So here's P, so what's P? So here's P, so what's P prime? 1, right? So that's 1. And here's Q, we just have to write down Q, so we just write it there. Okay, now, we need Q prime times P, right? Well, let's put the P first, it's just there, right? That's the P. So the only thing left is, what is Q prime, right? Q prime equals what? But Q, we said, is what? F of x squared, right? So the question is, what is Q? I'm sorry, no. Q is equal to that. So the question is, what is Q prime? Right? What does that mean that Q prime is, right? So how do we get the derivative of that? So this is an example. Okay, let's take a different one. Suppose I asked you, all right, let's review very quickly the chain rule. What does the chain rule say? It tells me the answer to this question. Let me write it like this, just to make it kind of similar to what we have. Tells me the answer to that, right? Do you remember that? It's the derivative when you have an inside function and an outside function. And the answer is that it's g prime of f of x. Now this is the opposite of the way I usually wrote it. Usually I put f on the outside and g on the inside, but because I had f on the inside there, I decided to do it this way. So times that piece times that piece. Right? Do you remember that? Okay, now let's take a more familiar example of this. For example, suppose I asked you, what is the derivative of that? Right? Okay, so what is the outside function? Raising something to the 100th power. So the outside function, we called it g, right? So the outside function is that, right? And the inside function is what? What's the inside function? Right? Okay, so now we've identified the outside function and the inside function. Now we have to use this rule. Okay? So let's just finish it anyway. So what is it? It's the derivative of the outside function. What is the derivative of the outside function?